Hello all, welcome to Code Hub. Today let us solve the Lead Code Daily Challenge, and the problem is minimum difficulty of a job schedule. You want to schedule a list of jobs in D days. Jobs are dependent. The jobs are dependent. That is, to work on the ith job, you have to finish all the jobs J, where J is less than I, greater than or equal to 0. Which means if I want to complete this job for I want to complete all these three jobs, and then only I can start this job. That's what they are mentioning. So you have to finish at least one task every day. Okay, the difficulty of a job schedule is the sum of the difficulties of each day of the D days. Sum of the difficulties of each day of the D days. The difficulty of the day is the maximum difficulty of a job done on that day. So what does that mean, difficulty? The difficulty means the maximum difficulty of a job on one particular day. So you are given an integer job difficulty of integer d. The difficulty of the ith job is job difficulty of I. Return the minimum difficulty of a job schedule. If you cannot find a schedule for the jobs, then return -1. Okay, what is the case for this? If I cannot schedule a jobs for then return -1. If I have 4 jobs, if I have 4 jobs and D is nothing but 6, then obviously I cannot partition this into 6 days. That is, I cannot partition this particular job for 6 days, because this total number of difficulty is greater than the days is greater than the total number of elements in the job difficulty. So I cannot schedule. If I schedule one job per day also, I cannot partition it for 6 days. So obviously I cannot schedule it. So the base condition will be, if my D is greater than N, then obviously I can return -1. I cannot schedule one job. Also, I cannot schedule for the remaining jobs since the N is lesser than D. Hope you understand what I am coming to say. Difficulty dot size. Okay. So if I have given the array 6 5 6 5 4 3 2 1 and D is 2, means D is days, so D is 2, then I can partition this particular array into 2 parts, which is 6, then 5 4 3 2 1, or else I can partition it as 6 5 then 4 3 2 1, or else another possible way is 6 5 4 then 3 2 1. Then another possible way is 6 5 4 3 then 2 1. Then another possible way is 6 5 4 3 2 and 1. So on day 1 if I do 6 and in day 2 I do these jobs, then this total difficulty will be the maximum of this is 5 plus 6, which is 11. So for this will be the maximum is 6, and here the maximum is 4, so 6 plus 4, which is 10. So for this the total difficulty is the 3 plus 6, which is 9, and for this it is nothing but 6 plus 2, which is 8, and for this it is nothing but 7. So we have to find the difficulties for each parts. I have each possible ways, and we have to minimize that. We have to minimize the difficulty. That is what the question states. So how can I visualize this problem is nothing but what we can do is partition the given array into D parts such that the difficulty is minimized, where the difficulty is nothing but maximum difficulty of a job on one particular day on particular day, not maximum, the sum of maximum difficulty of a job on particular day. So hope I have boiled down this into some other problem which can be understandable. So what are going to do is we are going to partition the array into d parts. So we are going to find out and go through all possible ways. So all possible ways is nothing but all possible ways always tend to consider the recursion solution. So recursion solution, obviously it may lead to exponential, which may give us TLE. So we may we may memorize the solution, and we will memorize the solution. After that it will become a DP solution, so it may get accepted. So we can first try to give us a recurrence relation for this problem. What I'm going to do is I'm going to have an answer return, or else I can say it as int answer, or else I will say it as long because it may give us a big value. I will call this function solve. This function solve is going to calculate the minimum difficulty. So how I'm going to do is, first I'm going to pass this array, then I may need an index, so I will represent that in a particular index I, and then I may read these d parts, then the size of the array. So hope this should be enough. So let us try to run try to define the function. So difficulty int I, int d, int n. What will be my base condition? What will be my base condition? If my d is 1, then there is only one day. So one day in the sense, I want to calculate the maximum among the left out array. So the for int k equal to I, k, that k starts from I till n. So the what will be the maximum? The maximum is going to be my max of max comma job difficulty of k is stored in my max, and finally I'm going to return this max. If there is only day, if my day is 1, then I should calculate the max to that particular partition, and then I am going to return that max. If d is not 1, then there may be a condition where I may reach the size of the array. If I reach the size of the array, then I will return a int max. Why so? Because I need to minimize the answer, so I am going to return a maximum answer. So whenever I come inside this loop, I want to calculate the maximum where I want to calculate the maximum so far. So I should have a maximum variable which is initialized to 0, and then I will have an answer, long answer. This is going to store our answer. I will have it as int max initially, and finally I'm going to return this answer variable. So I'm going to start from this particular index k equal to I, k is less than n, k plus plus. For each and every index k, I want to calculate the maximum so far, max so far. So the max so far is nothing but max of max so far, comma, job difficulty of k. And whenever I am going to the next position, either I want to go and serve for all possible ways, that is the answer is nothing but the minimum of, I will have another possible solution in long curve, and is nothing but solve the max so far plus the solve of next function, the job difficulty comma the k plus 1. From this partition you leave it, you do in the next partition k plus 1. Once I have done one partition, my d will become decremented, so the number of days will be decremented, d minus 1, and n remains the same. and the answer will be nothing but the minimum of the answer comma correct. And finally I'm going to return our answer. So hope this recurrence relation is understandable. Why so? We are taking into all possible ways, all possible stuffs. We can do it in recursion, and we will run a for loop for each and every particular index. I will calculate the max so far until now I have calculated, and I will partition that particular index, and then I will go to the next index, and my d will be decremented by 1. If my d is 1, there is only one day left. So from that particular index till the end of the array, I want to calculate the maximum and return that maximum. So that is what I have done in this code. So let us try to run our code. Okay, finally I have to return the answer. If my answer is equal to int max, then obviously I will return -1, else I will return my answer itself. Okay, let us try to observe what is happening here. 6 minus 1 2, 7 minus 1 3. N minus d, because if there is that much days, I should go till n minus d. Okay, no, I may missing this somewhere. Wait a minute. Okay, let us try to move the base case up, because if my I has reached the end of the array itself, then I will return max. Or else if there is only one particular day, then I will calculate the maximum, and then I will return the maximum. Yeah, super bit got accepted. Anyways, it will give us a TLE. So let us try to memorize the solution. How we are going to memorize it? We want to see the number of parameters changing. The number of parameters changing is I and D as well. So there is only two parameters changing. So I should declare a 2D vector, which is vector of vector long of size of dp of size n, and a vector of long of size d plus 1, which is initialized to -1, and then I will pass this dp, and here I will take this dp as a parameter. Then what should I do? Here I want to check for one condition. If my dp of I d is not equal to -1, then I will return dp of id. That is already it is there in our already it is pre-computed. Dp of id equal to answer, and I should pass this dp as well, and it should be sufficient. Superb, it got accepted. Let us try to submit our code. Super, it got accepted. Hope you like the solution, and let me know in the comments, and if there are any suggestion. This is the common DB problem with partitioning the array. So hope you like this video. Let us see in tomorrow's LeetCode Daily Challenge. Until then, bye.